What's going on? In this video, me and Scott are going to build a pellet mill for making wood pellets. You can use pellet mills for a lot of different things, but we want to take wood waste and make wood pellets out of them for heating, for maybe even like cooking if you really wanted to. But just would be a fun project to do. And I want to explain to you and draw you out how it works and how we're going to attempt to do it. I feel like there's not very many good explanations online on how it works. If you look for pellet mills, you find a lot of videos from China or other places where they don't really do much talking and explain what they're doing and how it works. So I'm going to draw you out a picture of it to give you a better idea. Alright, so I drew a little diagram of it here so you can see. You got two main components. You got the die and the rollers. And the rollers, they act like a steamroller would, and they compress material through the die. So they ride really close to each other. The die is stationary. The rollers spin on the shaft. And as material makes its way to the die, the rollers press it down through the holes. You can see a little cutaway I made right here where material enters up through the top, through a hopper, makes its way between the rollers and the die, and then gets pressed out as a pellet and then ejected out the side by a plate that's spinning with the shaft. So the shaft controls the rollers themselves, as well as this little plate there that ejects the pellets. And how the science of it, the way it works in my mind, and I think this is true, as material gets compressed down through the hole here, it heats up and it has releases some steam, which in turn releases the lignin in the wood, which is like the natural glue that holds it all together. So that makes its way through all of the material that's in the pellet being formed, and then when the pellet comes out the end, all that glue is all the way kind of through it, and then it cools to form a hard pellet. Let's get into learning, let's get into building this, and I hope you have a good time. Thanks for watching. Alright, so the first thing we're going to need is some sort of housing for it. Spotted this out in the boneyard earlier. I think this is gonna work. Big pipe. This can be our discharge, so the pellets will discharge out this way. But lug this thing over there. Oh, there it is.
That I don't have AR plates.
Yeah, I don't think we need to do it at AR. This one. I think we should probably, just for time's sake, just.
Well, I think for time's sake, and I don't see it wearing that much. I don't know how much it would wear or is going to wear.
Alright, I'm going to spare you from this insane chit chat we had here. Basically, we're going to talk about the die and the size it needs to be, the thickness it needs to be, if we're going to chamfer the tops of each hole so the material enters easier. We also talk about adding sand and different things to the mix to help smooth it out so the sand goes through there and kind of acts as sandpaper. We also talk about how we can flip the die over whenever one side gets worn out so we have more life in the die. And that's about it.
All experimental at this point.
Yeah.
We need to research a little bit more on the dyes. I know you sent that one link to me, but maybe we need to look at some other links to see if that's a standard, 1.25 inches. Would you quit this?
He's nervous.
Don't make me look like an idiot.
He's nervous. I have no idea how to run this thing. How to use this.
Oh, easy.
Alright. Doable.
Brake. Oh my God. The brakes work.
gotta cut some circles out of this for a different project Scott needs. But we'll cut our actual die plate out of this. That should be thick enough. So there's a ratio, and it's the thickness of your die divided by the hole sizes you're going to put in it, and it gives you your LD factor, I guess, or LD ratio. Apparently, the higher the LD ratio, the higher quality pellet. So you take the die thickness and divide it by the hole size, and you'll get to your number. But so if we do this, which is about 1.5 inches, I think it should give us an LD factor of 6 if we're going to use a 1/4 inch sized hole in there. So we'll try that and see what that's like.
All right, cable down. The Eagle has landed.
All right, we're gonna cut our die out of this plate here. 1.5 inch, mild steel, but it's so thick that you have to start on the edge because this plasma cutter cannot pierce it. What happens is it'll try to pierce it, all the slag and everything will end up blow back up towards the nozzle because of the compressed air, and it just ruins the end of your nozzle. So we'll just start on the edge and cut our circle there, and that'll be the base of our die. Send it back around and then hit the heat to get back to there.
I don't have a very good memory, but I think that's the thickest we've ever cut on this thing. You got that set at 11.5?
Yeah.
What is that?
A little bit less than a, what is that, a 16th less?
I don't know, what's that in metric?
Last thing I'm going to cut out here, out of this piece of 1/4 inch, is a circle that'll go on the shaft at the bottom, and it'll spin and eject all the pellets out. We'll probably make it on a collar so it slides up and down, and that way we can change the length of the pellets as they come out. So let's do that real quick.
Roller. So that'll be the shaft. That's where the shaft is going to come through. Let's see how well Carter did.
I don't know, this looks pretty promising.
Fine job, Carter. It
A
fits.
little bit of space, but
It's all right. So we'll get that hole drilled in the middle, and then we'll decide if we're going to turn anything off the outside of it.
okay.
Right now it's already a little bit small. Center. This is a centering square for circles.
Huh.
Doesn't even
Anywhere.
have to be, yeah. Let's try to go 90 degrees just because. So that's the center. That's where we'll drill our hole. That's the center, as center as it's going to be, depending upon how round it is. You know, if it's a little bit oblong, this one over here is not going to be quite centered, but it is definitely close enough for a pellet mill. What did I say? We're not the best, but we're the cheapest.
What is this, Matt?
Snow cone?
Now eat it, yeah. What's going on here?
It's three-phase.
How you change the turn the motor into a three-phase for this? I feel like that's cool. Explain that.
That's a little fella. I only have single-phase electric here, so in order to run a three-phase piece of equipment, I have to generate the third leg. So there's a starter. That box down there starts that motor. It's got single phase going into it, 2 poles. And that starter box is full of capacitors that snap starts that. And once it's running, the third leg that is not hooked to the incoming power is actually generating power going back the other way, which generates the third leg for this.
That's cool.
That's what I got out of it anyway. I don't know if it's true or not. But
Well, it works.
that's my story. Let's see. There you have it. That is called a core drill.
Core drill.
Annular cutter.
Annular.
I just call them core bits. So that's 0. If you want to start on 0, and then we'll see how many degrees it takes to make the next hole. You know.
And you want me to just try to stack them all together? But because then how do we know? Because once I start, like, what if there ends up being gaps, where it's like that one wouldn't?
You know, I don't know how you would.
Unless you wanted to do like a grid pattern instead of a circular pattern, you do like lines of them. Like,
well, you can do that too. You could just keep moving this way.
Yeah, and then
when you get to the end one, move over so many degrees, because you're gonna have to stagger them. You won't be able to put them in line.
yeah,
So you get this row done, and the next one you move into the center of them two.
yeah.
It's not gonna work out.
It's not gonna be as pretty as I want.
No. I don't know why it does that, but it does it. Mike just has to eyeball it.
All the holes? Alright, so basically in this part we're going to take it and just go line by line and just move at set distances between each hole, and then we'll move over and do another big line and just a grid pattern all the way to the end. Because if we were to try to rotate that little stand he put it on, there's no way it would have lined up at the very end. It would have probably ended up looking pretty sloppy, so.
Probably close all that up.
Try to get this done.
You ain't gonna get this done. You'll be here tomorrow morning yet.
I've been doing this for almost 2.5 hours, and this is how far I got. This is gonna take a long time. But I'm calling it quits for today. It's a new day. I got these cobalt drill bits, so let's keep going. Alright, went to go get lunch, and I guess during that time Scott went and got some cutting fluid, which I desperately needed, and whatever this is, cutting compound, completely organic, whatever that means, and some other drill bits here. So we will give them all a shot and see. Still going. Add 2 hours to that. So this is how far I've gotten within 6 hours, plus the 2 from the other day. So this is what 8 hours of drilling 3.5 inch looks like. Another 2 hours. 10 hours total. Another day. 4 hours. 14 hours of holes right there. Guess I'll see you another day. Well, the last row. I can't even believe this moment has come. Today I'm 6 hours in. Let's see if we can get it done. Here it is. The moment I've been waiting for. The last hole. Can't even believe it. There it is. 3 inches. That's insane. That took a long time. There it is. 20 hours total for this piece. Guys, I would never recommend this ever. If you know someone with a CNC machine, or even just hire someone to do it. I sharpened these bits like 8 times. I had 2 of them I switched between. And I'm not very good at sharpening, and I had to learn how to do that. But I mean, it just takes up so much time. I think you should just, if you had a CNC machine, or if you know someone with one, just do that instead. I don't know why you'd ever do this. Nonetheless, it's not perfect, but I still think it looks good. Good enough for what we're gonna do. And if we ever had to do another one, definitely gonna hire out a CNC or find someone with it or something. Alright, I actually ended up counting all the holes, and apparently there's 621. I probably missed one, but I mean 621 1/4 inch holes in an 1.5 inch thick plate of mild steel. No wonder it took 21 hours, basically 20 hours. Only thing left to do now is clean up. Looking a lot better. So in this video, we made the die. We also made the block. So this block, well, imagine that this stuff's not here. It will sit in the middle there, and then the rollers will come out either side, and then it'll spin on the shaft. The shaft will run through this. We got this plate cut out, which will attach to the shaft, and it'll be where the pellets come out, hit this, and then it get ejected out the pipe here. And this pipe will serve as our housing. So we got a lot done. Still got a little bit more, but we'll see you guys next time.